Hello again. In this video, we're going to learn how to do transformations of linear and absolute value functions. More of the focus will be on the absolute value functions. Linear are just y equals mx plus b, but we will be applying a little bit of the format in which you would use translations algebraically instead of bin by graphs. So here we go. So we have horizontal translations. So again, a translation doesn't shift anything or change its size or anything. It just moves it right and forth. I don't know if you can remember like a transformation. That's when it changes size and everything. That's when there's an a value. So horizontal translations go right and left. Vertical translations go up and down. The horizontal translations have to do with the h value, which is inside the parentheses. And the vertical translations have to do with the k value, which goes up and down. Okay. All right. So I know that it looks like there's two problems here, but there's actually four problems here that we're going to do. I'm going to separate this in half. I'm going to separate this part in half. Okay. So here's the original function. So the original function f of x is 2x plus 1. Now there are certain things that need to be done. So we have part A and part B. So for part A, they would like us to do a graph whose function is translated 3 units down. So I'm going to write the original graph, f of x is equal to 2x plus 1. This part, when it says 3 units down, that's a vertical translation, so that's k. So that means we're going to subtract 3 from the k value. And now this is a g function, so the g of x function will equal 2x minus 2. So we applied the 3 units down, and this was the result. And our new answer is the g of x equation. For the second one, for b, we're going to write the function, the f of x function, 2x plus 1. Then the g function, or excuse me, the h function will be a graph that's translated 2 units to the left. So 2 units to the left is going in the negative direction. But remember that for the g of x, or the h of x, then this is the part that's going to be affected by 2 units to the left. So this will become 2 times x plus 2 plus 1. So the only part that's getting affected is this, and it's changing to x plus 2. Remember, for the h value, it's opposite of what you think, and this represents h. Okay, so because it's going to the left in the negative direction, it's basically minus a negative 2. Now we're going to multiply this whole thing out. So we're going to get 2x plus 4 plus 1. So my h of x function will be 2x plus 5. And nothing happens to the k value. Pause the video and please try the next problem and see if you can figure out how to do that. Okay, once you come back, so here we go. So for part A, we have the f of x function, which is the absolute value of x minus 3. They want us to write a g of x function that's translated 2 units up. So 2 units up would be here. So the g of x function would equal the absolute value of x minus 1. And that's k. For the next one, we have still the f of x function that we start with, which is the absolute value of x minus 3. And for the second problem, they would like us to go 4 units to the right. So that's h. And so when we write that, 4 units to the right, we're going to write x minus 4. The h function, so h of x. So the only thing again that changed here is that we put a -4 inside. Okay. Now for the next problem. Here we have reflections in the x-axis, which make the entire function negative. Okay, so the entire function will be negative. And then we have reflections across the y-axis. So reflection across the x-axis is this way. Reflections across the y-axis are this way. And this one makes the x values negative. Okay, so this is the entire function is negative. And for reflections across the y-axis, the x values become negative. Okay, those are two different things. So again, we have 4 different problems because we have an A and a B for both. So I'm going to start by writing the regular function f of x is equal to the absolute value of x plus 3 plus 1. For the first part, they want a reflection across the x-axis. What that does is it makes the entire function negative. And since it makes the entire function negative, all of this will become negative. And there are only 2 parts. You have the absolute value part and then the numeric part. So when you make the entire function negative, there are 2 parts to this that become negative. So we are writing a g of x function, and the absolute value becomes negative, so it's a negative absolute value, and then the k value becomes negative. If they were already negative, they would then become positive. Basically, you do the opposite of the absolute value and the opposite of the k value. You do not touch anything inside the absolute value when this happens. For the second part, you rewrite the original function. Okay, so f of x is equal to the absolute value of x plus 3 plus 1. Now, we are going to do the second one. Let me choose a different color. H, and it's a reflection across the y-axis. So what that happens is the x's become negative. So anything that was a positive x will now become a negative x. Everything else stays the same. So for my h of x function, the absolute value stays the same, that stays the same, and then that stays the same. So wherever you had a positive x now becomes a negative x. The only problem here is that we don't really want to leave a negative x on the inside of this when you're doing an absolute value. So in order to get rid of that, an absolute value is kind of a weird thing. It doesn't make the negative x positive and the 3 negative. What happens is you can change the sign of both of them and to make the x positive. So in the future, I'll let you take the shortcut where you can just change the sign of both things. However, let me show you why that works. So if I factor out a -1 from both of those, and I can rewrite that as x minus 3 plus 1. So again, from these two values, I'm factoring out a -1 in front. And then you could rewrite h of x as the absolute value of x minus 3 plus 1, because the negative sign, or the -1 in this case, will become positive. In the future, if you would prefer to just not leave the negative x negative at the beginning, it's just a weird way of writing it. It's just a better looking way of writing it. So instead of writing -x plus 3, which is not incorrect, we would like to lead with the first number or the first variable being positive. And in order to do that, you need to change the sign of both of them. And that's it. So that would be the second one, so that you're not leading with an x. You can only do this for absolute values. For the next problem, you guys should try these both, please. And then I will come back and you can play the video afterwards to make sure that you did this correctly. For both a and b, I am going to write the f of x function. And I'm just going to make this bigger so it makes it a little bit easier. For the first one, we're going to write a function g, which is a reflection across the x-axis. So again, when you have a reflection across the x-axis, it just means that the entire function is negative. So this means that for the g of x function, we take the f of x function and the entire thing becomes negative. So it becomes negative 3x plus 4. And this is just a linear equation. It just makes it a lot easier to kind of see what's going on. For the second problem, we have an h function, and it's a reflection across the y-axis. So that means the x part is negative. So for h of x, everything is exactly the same, but the x becomes a negative x. And that's it. So that's the only thing that changes, and then we have to simplify this. So this becomes negative 3x minus 4. And that's how you do the first two examples. For number 3, we will be writing stretches and shrinking of functions. And when that happens, you multiply the entire equation by whatever they ask you to do. So, and there are horizontal ones and vertical ones. So let me go over those. So we have a vertical stretch, and that means that you multiply the entire function by the a value. And then you have horizontal stretches, which means you multiply the x value by the reciprocal of a. All right, so here we go. So for the first one, we have f of x is equal to the absolute value of x minus 3 minus 5. They tell us that we have a stretch, a vertical stretch, by a factor of 2. What that means is that you will multiply the entire equation, or the entire function, by 2. So again, when you're multiplying the absolute value and you're multiplying the k value in this case. So we're multiplying both of those by 2. You don't distribute inside the absolute value. So this gives us 2 times the absolute value minus 2 times the k value. And that will be your, they want h, your h of x function. For the second one, this one's horizontal. So again, we have the f of x function that's given, the absolute value of x minus 1 plus 2. And in this case, they want us to do a horizontal stretch. So to do a horizontal stretch, in this case, you take the, and it's 1/3. So we're going to take the reciprocal first. So the reciprocal of 1/3 is 3/1, or 3. And then we will multiply a, or x, by 3. So in this case, we have f of x is going to be, not f of x, excuse me. This will be h of x will equal 3x, or 3 times whatever the x value is, minus 1 plus 2. For number 4, we are going to be using combinations. So we're going to be using both different types of transformations in one question. So what we have is, it says let the graph of G be a translation, I'm reading here, of 6 units down followed by a reflection in the x-axis of the graph of. So we have f of x. I'm going to rewrite the original graph that's given. And the important thing here is that you have to go in order. So whatever is written first has to be done first, which affects the entire problem if you go out of order. So the translation of 6 units down. So 6 units down will be to put a -6 here. So actually, let me rewrite this. So it will be the same equation that you have. And then we have a -6. The second part of this equation is to have a reflection in the x-axis. When it says in the x-axis, it means across the x-axis. So a reflection across the x-axis means that you're going to make the entire equation negative, or the entire function negative, I should say. So that part means you're going to do a negative. Let me erase this. I'll write it bigger so you can kind of see what's going on. You'll make a negative absolute value of x -6. Remember, when you're distributing, it never distribute inside the absolute value. So you're going to have a negative absolute value of x. And you're going to have a negative -6. So the absolute value will become the opposite sign. And the k will become the the opposite sign. So it's going to become +6. And this will be g of x. So inside the absolute value, you don't change the sign of that. For the second kind, we have this is a modeling question. So in this question, you're going to design a computer game. Your revenue for x downloads given by f of x is equal to 2x. So this is f of x is equal to 2x. And x stands for the amount of downloads you have. So your revenue is basically 2 times 2x, the amount of revenue. Now, it says your profit, so now we're going to be doing profit, is $50 less than 90% of the revenue. So we have to do 90% of the revenue first, okay? So this is revenue. They should have used r of x. That would have been nicer because it would be easier to understand if you did r of x is equal to 2x. Then the profit is $50 less than 90% of that. So you do 90% of this first. That would be 0.9. 90% is 0.9 times 2x, which is 1.8x. And then $50 less than that. So then you have to do $50 less than the 90%. So that will be 1.8x minus 50. And that stands for the profit. Okay, so write the function p. So p of x is equal to this. So this is the revenue, and this is the profit. So this is how much money you make after you pay your costs. Okay, the revenue is just how much money you make in general, disregarding the costs. And then the final question says, what is your profit for 100 downloads? So we're going to use the profit function. And x, remember, stands for the number of downloads. And so if I want to know how much profit I'm going to make for 100 downloads, that will be 1.8 times 100 minus 50, which will be 180 minus 50, which will be $130. The profit for 100 downloads. Okay, so profit, if you want to write it out, for 100 downloads is $130. When you write money, please put the dollar sign in the front, not in the back. Even though you say $130, you do not write the dollar sign after the 130. even though that's done quite often in social media and other places, it's not accurate.